Okay, so the null space is a set of all vectors that give us the zero vector. Now, what do I mean by give us the zero vector? Well, we're talking about the matrix A. Okay, so this is the set of all vectors, to be more specific, such that A times x equals 0. It's a set of all vectors x such that AX equals 0. Those are the vectors that give us 0 when multiplied by the matrix A. Okay, so how do we determine the null space? Well, we can reduce the augmented matrix. Okay, we have the AX equals 0, so we take the A matrix here and we put a row of zeros augmented with a row of zeros, and now this represents the system of equations that you would solve to solve for x such that AX equals 0. Another way of denoting this matrix would be with brackets, and we have A and then the such that sign and 0 vector. Another way is the way we did it up here, A augmented by 0, 0, 0, 0, 0. In any case, when that's reduced, it's clear that the zeros are still going to be there. So if the reduced matrix is this, then this is what we're going to get when we reduce it. Now, what does that tell us? Well, we translate that into a system of equations, x1 plus 2x2 plus, something wrong there. I said plus x3 equals 0, but this would be the x4, wouldn't it? So that means my solution over here isn't correct. So we'll fix that. Okay, so I should be plus x4 equals 0. Okay? The second says that x3 plus x4 is 0, and the third says that x5 is 0. Okay, so what I have over here is no longer correct, so let's just work it out. We can see that we have 3 equations in 5 unknowns. That gives us 2 free variables. Now x5 is not free. We know that x5 is 0. Okay. And then since x3 plus 3x4 is 0, that tells us that x3 equals negative 3x4. So if we take x4 to be one of our free variables, because that occurs up here as well, let's let x4 equal s. So s is the value of our free variable x4. It follows then that x3 is negative 3x4, so x3 is negative 3s. Now up here, x4 equals s, so that x1 plus 2x2 plus s equals 0. Now, that's about as far as we can go. We've used all of our information, and we still have x1 and x2, 2 independent variables. So one of these is going to be our free variable. So let's let x2 equal t. So now this equation becomes x1 plus 2t plus s equals 0. So x1 is negative 2t minus s. And now we have values for x5, x4 is s, and in terms of s, then x3 is negative 3s. To get x1, we use x2 as a free variable, call it t, and we find that x1 is negative 2t minus s. And of course we've got x2, so we know what x1 is in terms of our 2 free variables now, t and s. We know what x2 is, we know what x3 is, we know what x4 is, and we know what x5 is. This allows us to represent our solution. Now, I hate to make you wait while I do this, but I'm going to kind of wipe out all this stuff because it's wrong. And now let's see what we've got. Okay, so our solution is x1, x2, x3, x4, x5. I should have waited to make my bracket, but there we go. And that equals what? Well, x1 is negative 2t minus s. x2 is t. And again, I've made my bracket a little prematurely, I think. But anyhow, x2 is t. x3 is negative 3s. x4 is s. And x5 is 0. Okay, so this tells us that any vector x that satisfies this equation ax equals 0, and that means any vector x in the null space has to have this form for some t and some s. Also, for any t and s you might want to choose, this vector is in the null space. This vector always maps to the 0 vector, if I've done the algebra correctly, and you can check me on that. Now, what we're asked to do is we want to find a basis for the null space. Okay, so, well, we can take this just a little further then. We can say that this equals negative 2t, t, 0, 0, 0, plus negative s, 0, negative 3s, s, 0. And something doesn't work out. Okay, well, that's okay. I don't think there's any way around it. Okay, so anyhow, how did I break this down into this? Well, first of all, let's verify that this equals this. It's easy to see. Negative 2t minus s, if I add these, I'm going to get negative 2t minus s for my first number. Well, there it is. If I add t and 0, I get t. 0 and negative 3s gives me negative 3s. 0 and s gives me s. 0 and 0, of course, it gives me 0. How does this help find a basis for the null space? Well, we've just about got it. Factor t out of this. And I've got this result. This means that any vector in the null space is equal to some t times this column vector plus some s times this column vector. Well, that's just a linear combination of these two column vectors. So these two column vectors, and I'm going to write them in row form. That this set of vectors is a basis for the null space. I'll get out of the way and let you look at that. Okay, that's what we have. This is a basis for the null space. Now there's more that can be said, and I'm going to say a little more about what should have happened. I can verify from this that there's something wrong in here with the arithmetic, probably something wrong in developing this matrix A, an arithmetic mistake. So I'll show you how I figured that out.